called Lucky Numbers. And Lucky Numbers is a game where you form rows and columns in this grid in ascending order. There are 20 cards from 1 to 20. So it is like kind of important to place your cards in the right position so that you like maximize your chances of forming the connections. So right now we are just trying to see whether we can like create the game first before creating the AI. So this was supposed to be done like last week, creating the game, but it took longer than expected. So yeah, there are some stuff like you can replace the card here, or you can like kick out the card. So right now, there's something wrong with the logic. So you can see that these buttons are being highlighted. So this supposedly are the areas where you can put your cards, but as you can see that there's something wrong with this logic to choose it. So let us try to solve this problem of putting the right cards, putting the logic for the cards properly. So to do that, we need to go to our game manager, our trusty game manager, to edit the code. Yeah, actually, I just wonder like because this game has a little bit of luck. So if we were to use like machine learning algorithms for this, it will be difficult for the machine learning algorithm to learn with just one instance of the problem. It's just like poker. Like they have to average it out over all potential instances. Yeah, which will make the algorithm take longer to learn. I mean, indeed, because I've been playing this myself for the last few days as well, it is difficult to actually learn whether your move is correct or not, because you sometimes might get lucky and think that okay, yes, I should make a move at this certain square because I wait for another piece on the right. It could just happen that you are just lucky. So it is a matter of maximizing probabilities, something which we don't do very well. Humans don't do very well on this kind of probability stuff. The time machines can perform better than humans at games like poker because you know if you go by expected value calculations, the machines do better than us at that. Yeah, so that's why like in terms of stuff like uh, finding the probability of the next word in a sentence, machines can do that very well because they just use their training data set, and they see what is the most probable next word based on the historical trends. Like GPT-3, they do something like that. Okay, just that they do it not only at the word level, they do it also at the sentence level and paragraph level, probably. Okay, so what we get here is, let's go to the place. There we go. So this return neighbor value supposedly returns a value if, okay, the up, down, left, right, um, the current number is greater than that one, then a label is true. Okay, so I think that there's a slight issue with this. Okay, is because sometimes when you have your neighbor, okay, let's play this. Okay, sometimes when you have a neighbor, the neighbor might be an empty square. Okay, something like this, an empty square like over here. So an empty square is given value 0. Okay, so because of that, you cannot place on any of these empty squares. Yeah, like over here you can place here, but this somehow you see you can place on these empty squares here, which shouldn't be the case. Like over here you can place here, shouldn't be the case. I mean, here is 0 and down here is 0 as well. Okay, unless my function to take the neighbor is wrong. Okay, so let's try to see how to solve this. Okay, my screen is slightly lagging. Okay, let's stop the play button for this. Okay, let's see how to fix this. Okay, so we have current number greater than left, greater than up, smaller than right, smaller than down. Okay, so if, yeah, I think this is wrong. Current pause greater equals to 12. Okay, let's see the squares again. Where's the squares? List of squares. 12 will be here. Yeah, actually it's correct. Yeah. So if it's we return the largest one, and then we put an offset of +4. That's correct. Okay. So if it's playable, okay, then we will activate the button. All right. And then we activate the clover if it's playable also. So I would like to change this function here. Okay. Because I think this function is not able to handle the blank spaces. So instead of doing this, what we can do is we could have, okay, okay, maybe I should call a function called check playable. So we could have something like that, and then we will return this. We will return an array to this. So playable. I wonder if I could return an array like that. Yeah. So we put this whole thing here inside a function called check playable. Void. This is not void. It's more like an int. I think it's possible to return an array. Yeah, we can just return the pointer, right? Yeah. So basically, we are just doing the. Okay, let's just see whether if I put the code over here, all right, will will it still work? Will it crash? Okay, so that's what I want to find out. So let's see whether there's any errors in returning this array. Okay, so I just want to see whether this works. The name current num does not exist. Okay, so this should be a bool. Okay, it's not an integer array, it's a boolean array. So let's see whether this works. So if this is the same as just now that script, it should give us the identical performance when we play the game. Um, yeah, we're supposed to get the same performance when we like have the cut down there. It should be the same. Yeah, looks like it's working. Oh, in fact, this is correct, isn't it? Yeah, like, oh, now this looks correct already. Just now it was slightly wrong. Not sure why, but it seems to have solved the problem, right? See, only you can only replace here, which is correct. Yeah, so 3 you can replace this, yes. Actually, you can also replace like stuff like here is 12. Okay, just that when we have a blank connection at the bottom, okay, we treat it as a 21, or we treat it as a 0. Okay, so if it's blank, we treat it as a 0. But what we should do is when there's a blank down here, we should go all the way to the bottom, okay, in order to find out what is the like what is the maximum number at the bottom. Yeah, so it looks like based on the current code right now, somehow this seems to be making it work even better. Okay, so I think this return neighbor value, this code is correct. Okay, so we need to enhance it a bit so that it can give us the return value of all the cells all the way to the bottom and all the way to the right. Yeah, stuff like that. So let's see how what I can do for this. Okay, so I think what we need to do is we need to create two. of four different arrays, integer, like that, integer. That's how we do it, right? Integer, yeah, integer, left. Okay, so for each cell, we want to do the maximum from the left, maximum from the right, minimum from the top, minimum from the bottom. Like we will go through from the top, we take the minimum value so far until it encounters a number that we change the minimum accordingly. So what we can do is like this. Min up, min, oops, min up, min down, min left, max up, max left. I'm thinking whether there's a more efficient way to do this. Maybe I just need a min and a max. Okay, then in this max value and min value, what we do is we'll go through from the top to bottom and we'll update it. Yeah, let's do it. Yeah, we can do more than one value with math.max. So we can do this. We return the value of it. So this return neighbor value has some use after all. It's not completely wasted because we need to find out the value of the cell on the left, find out the value of the cell at the top, okay, and then also zero, which is the base value. Okay, in case actually we may not need zero because over here there's a zero already. So we can just take the cell on the left, cell on the top, okay, and then just return that value of the maximum, and also probably mm, we need to return the mean value. It's not just the neighbor value. Okay, the neighbor value might change. We need to also put in this mean value somewhere in this equation. So it's like you have mean value of the left and the top, yes, but we also need to take into account this mean value. So probably, let me just adjust this function a bit. That allows us to pass in an array. So I want to pass in either a boolean array or an integer array. How do I do it? So what I could do is, instead of returning this, or I could come up with another function that instead of returning grid cells, I will return the max value instead. Okay, yeah. So maybe we could do something like int position equals to 0. So over here we just make this, actually I don't need this already. If the array name is equals to grid cell, then return grid cell position, else return. Okay, there's a slight issue here because mean value and max value are created here. Okay, they may not necessarily be passed over here. So what we can do is, okay, maybe let me search how to do pass generic type as function in C sharp. Maybe I need to use a generic type here in order to pass in either int array or bool array. Uh, return array position, something like that. Yeah, let's try this. So this one we just remove it. Okay, we just remove this entire paragraph. Okay, mean value equals to return neighbor value I left. Okay, you know what? Actually, I just need to return the position, isn't it? Yeah, I don't have to do something so complicated. I just need to return the position. We just need to return the cell index, right? So essentially, we're just returning the position. So if all this, okay, this one we just return -1. And we just return the position. Okay, so we don't have to make it so complicated. Yeah. Okay, so very simple. Mean value I equals to, okay, the return neighbor position, return neighbor pos. Okay, make it as least as, so this one just returns the cell index of the neighbor, up, down, left, right. Return neighbor pos I left. Let's say something like that. Okay, then over here we have like grid cell. Okay, so what we need to do is like this: integer left value, right value, left value, and up value. Okay, left value equals to, if left value greater than 0, mean value I, okay, equals to mean value I and, okay, and grid cells left value and mean value left value. If up value is greater than 0, and here we probably don't need to do a mean value I, because here we did already. In fact, we don't need this. We can just use this. Uh, Now we need to do a mean value I with cells up value. Okay, so we take the grid cell at the top, or we take the grid cell at the left, and we also take the mean value at the left. Okay, just in case this mean value at the grid cell is different. Okay, so ideally, actually, we just need to compare the mean values. Okay, but the mean value itself must equals to the grid cell. If not, this comparison would be false. So let me think of how to phrase this well. Okay, so we need to put the mean value here. The How about this? Because the grid value will always be the constraining value, you see. So let us just put the mean value as this first, and then after that we just compare with the, because the mean value before that would already contain the grid cells value, right? So we could just do like that: mean value I equals to mean value I and mean value left value, and then up value will be mean value I and mean value up value. Yeah, we don't need the grid cells method anymore, because the grid cells will be minimum value is at least the current cell on the grid. Okay, so we do this. Okay, then maybe what we can do is we can print mean value. Yeah. Okay, let us do the same thing for max value. Okay, just that max value is a little different. Max value we start with 31 and then we go backwards because we want to start from the bottom right and we go up. It's because the max value we compare the right and bottom one. I don't know how an AI is going to program this, man. This is so difficult. Maximum value is at least, yeah, the current cell on the grid. Okay, so max value will be like that. And then what we have is now we have a down value, a right value, and a left value. Yeah. So actually all this should be greater equals to 0 because the 0 index is valid also. Right value, down value, and then we print out the max value. Okay, so in order to check whether it's playable, the mean value, the current number must be larger than than mean value and smaller than max value. Okay, so max value is basically the, if you look at max value over here, okay, it must be smaller, okay, than the right neighbor and the bottom neighbor. Okay, then also there's this thing called the actually should I put the max value as the grid cell? Okay, because if I put the max value as the grid cell like 17, I want to be able to change the grid cell regardless of what's above or below that grid. Yeah, yeah, I think this is not a good idea. We shouldn't make the current grid cell as the, yeah, let's just add another component, grid cells left value. Let's copy and paste this to every single one. Yeah, up value, grid cells right value. Yeah, so we only want to do it based on the neighbors up and down. Okay, and then we update the mean value according. So the mean value is like a memory placeholder such that when you traverse down this array, you remember, okay, you remember what are all the like previous minimum above you and so on. Okay, 190 semicolon expected. Did I miss out a yes, I miss out semicolon. Okay, so we have this mean value down. Okay, the cell must be larger than the mean value and smaller than the max value. Let us check. Okay, if current number greater equals to mean, actually not greater equals, greater than mean value I, and so it's a more detailed check in this case. We not only check for the immediate neighbor of the cell, we also check for the mean value and the max value, which actually stores all the previous memories of, like mean value stores the previous memories of the cells above and to the left. Okay, and of that particular row and column only. Okay, because when we do this, yeah, we actually check the top left and the top. Okay, this should be math f dot min. Yeah. Okay, this one we remove it. Actually, maybe I can just put here maximum value, checking the right and down direction. Minimum value, checking the left and up direction. Okay, so current value, current nums greater than mean value, and current nums smaller than max value. Okay, then playable I will be true. Okay, so that's all for the code for checking playable. And let's cross our fingers and hope that this works. There's quite a big chunk of code that I've typed out. So let's just pray that it works because okay, so this is the mean value 0.44444. So okay, this cell is 0, mean value is correct 4444. There's 4, so and here this value here 0.4444. This value over here, it should be the mean value of the top and the left. Okay, there's a slight problem right now because if I take the value of the top, okay, it's supposed to be 0. Okay, it's supposed to be 0, but because of the 4 over here, it became 4 as the mean value. So this one's supposed to be able to replace a bit smaller. So you can see that right now there's no cell we can replace. Okay, so the mean value part, I think I coded it wrongly. Okay, let's see how to fix it. Let's see how to fix it. Okay, so the mean value, if you look at how the mean value is printed, 4, 4, 4, 4, 4, 7, 7, 4, 7, 7, 16. Okay, it's not very easy to visualize here, so maybe what we can do is like that. Instead of printing min and max here, I create a function called print pretty. For int I equals 0, I smaller than array dot length I plus plus. Okay, actually I don't need to do this. I'm just testing out whether it can work. So what we can do is we have if I, okay, so we have a string. So maybe what you can do is like this string to print. Okay, if I percent for, okay, to print plus equals to slash n. Okay, else to print plus equals to a space. Okay, so what we can do here is to print plus equals to array I dot to string. Yeah, so if it's 0, okay, then we do a slash. Actually, it should be if it's 3, okay, then we do a slash and not we do a space. Expected in line 188. This one, okay. So this will print our, okay. Trying to do something fancy, but no. Let's just go back to ints. Yeah, because if we do a typecast like that, I still haven't learned it fully yet, but I think you need to define like certain values like I enumerable or stuff to impose the value length to it. But yeah, as of now, I just want to print the max and the min array. Oh, it's a small issue. I forgot to print it out. Yeah. So this printing function was just purely for error checking. I just want to see what is my min and my max array when I print it out. So let us see. Amazing, right? A simple game like that can be so hard to program. 15, 15, 15, 15, 15, 15, 15. Why are, oh yeah, there are two grids. 18, 18. The problem is like this grids here somehow is taking the value of the previous position. Okay, it's supposed to start anew. Okay, supposed to start from zero. So it's the mean value, the max value, it's all zeros. Oh, I see why. Because if we were to take the mean value of the current position, okay, I see why. This is actually max value, it's not mean value. I did wrongly here. Okay, let us see whether if I change the mean and max accordingly, do I get the right answer? Okay, let's see. Let's see. Okay, we're gonna play now. Play this now. 4466. 4444 666. Actually, it looks like it's okay. 9910. Yeah, looks 4. Here's a 4. Why? This should be a 0. 9919. How did the 19 come here? The 19 is all the way here actually. Oh, and this is all zeros again. Okay, because the max values are initialized to be max values here should be 21. Yeah, I should initialize the max value to be 21. Okay, so C sharp initialize array to value. Oh, I guess they don't have like a way to initialize it with, yeah, it's not like C sharp. It's okay. All you can do is you can just initialize like that max value. Yeah, we could just do like that. Okay, so that our max value won't be at all zeros. It will start at 21. Okay, and let's see how this works. Okay, it is still not correct fully, but at least I want to see some progression between the mean and the max values before we try to solve it the next round. So okay, you see 20. Oh, the moment it encounters a zero here, it takes on the value zero. So the empty cell over here, okay, the empty cell over here should not be a zero for the max array. It should be a, so the mean array looks like it's okay, right? I mean, I wouldn't say it's totally okay because like somehow this tree value gets popped over to the next level, okay, when it shouldn't, okay. Yeah, not sure why that's the case. Yeah, because the up value should already cancel it out. Yeah, unless over here I didn't return -1, -1, -1, -1, -1. I should just set this to be -1, right? Yeah. So there's something wrong with this because the moment the grid cells have a value 0, okay, okay, it's going to, how about this? We have to do another one here. So like, yeah, if the grid cell is a value 0, I don't want to include it. Mm, I think the best way is to do it like that. Yeah, yeah. So if the grid cell is a value 0, then we put it to be 21. If not, we use the grid cell's value. Okay, let us see whether this like sort of works. Yeah. Or actually, the easier method will be we just take a cell and then we just go all the way to the bottom, and then we find the largest number that can be put there. So 21, 10, 10, 10. Yeah, looks good. 21, 21, 20. Yeah, but it's somehow not replicating for this part here. This part here should be 10, 10, 10 also. Yeah, 21, 21, 21, 21. Somehow this part here, the top part is not reflecting. So it's like here, this down value. Yeah, I have to solve this later. I don't have time right now. Let me think about how to solve this. Okay. I mean, if this is too difficult, we'll just do like a single cell and then we just keep looping down until we reach the end of the grid and then we find the largest neighbor and then we just do that for each cell. I mean, it shouldn't take too long because it's a small grid. Yeah, I thought this method would be faster, but apparently it has some issues. But you can see like over here, looks like looks like it's actually displaying the right thing, isn't it? Like here, 12. Yeah, I can replace this. Okay, over here there's some issue. This part is not being shown. Here is wrong actually. Here shouldn't be shown. So there are still some issues that need to be sorted out, but looks quite promising so far. And we will continue fixing this issue in the next stream. Okay, see ya.